ठीक है.
To this webinar hosted by NEDAC Board 2023-25. I welcome you all on behalf of President NEDAC and all of our NEDAC board. Thank you so much for taking out time today in this summer morning, Saturday morning weekend. So really, really, really thank you for that. And I'm sure that it will be worth it. Another thing that I want to bring to your attention that it's good to see you all virtually, but we are looking forward to see you all next week. Our social secretary, NEDAC board, have organized a picnic that you all know. It's a cruise that's going to happen downtown Toronto. The cruise will last for 2 hours, and I'm sure that you all have got your tickets for that event. And we will talk about it in the end as well when we have the full audience. And without further ado, I'll pass it on to OWAIS to start the presentation. Thank you so much.
Sure. Thank you very much, Asma. I'll turn my camera off and start sharing my screen. So let me know when you see my screen. Okay.
Yes, I can see it, and I hope everyone else can see it too.
Okay, thank you very much. Well, I appreciate the opportunity to present my area of interest and passion so that I can pass on the motivation that I have in me, and not just to the experienced folks like you are, but also you can pass it on to your generation as well to see if they're interested in this industry or not. Very dynamic industry, as you will find out in the next few slides. So a couple of housekeeping items that as I present, if you have a quick question, please feel free to ask. But if you think that the question is more of a discussion type, then I would ask you to just hold on until the end of the presentation. Then I'll be happy to have a discussion and get your feedback on it. So with that, I'll go ahead and show you what the content of the presentations are. Of course, I'll introduce myself, who I am, and then I'll go over the history, the size of automotive industry, and who is automotive industry is for. And then, of course, the future trend of the automotive industry. And then at the end, I'll wrap up with the question and answer, and of course, feedback if you have any. Okay. OWAIS IQBAL, I have a PhD. I'm a technical fellow at the STELLANTIS, and I'm also a simulation method lead. If you are a mechanical engineer, then you might know what fluid dynamics is. So my area of expertise is computational fluid dynamics. The timeline of my life after NED, I graduated in '93. I worked there for a couple of years. Went to Saudi Arabia, King Fahd University, did masters over there. I met my mentor, Asad Asghar. I think he's in the attendance today. And then I followed his footstep to go to US for a PhD. And then over there, I have my 2 kids. And then after the PhD, I moved to Canada after working a year as a postdoc and so on. So my first job after my graduate studies is the automotive industry related, and I've been working in the same company ever since. Though I moved out of the US, but luckily or unluckily, whatever you want to call it, I got hooked up with the US company, and I've been working ever since with them. I started working in Canada for Stellantis. At that time, it was Chrysler. Then it was bought out by Fiat. So we became Fiat Chrysler Automobile. And then 2-3 years ago, we got a merger with the Peugeot. So now we call ourselves Stellantis. But I've been working with the same company first few years in Canada, but now my workplace is in US, Michigan to be exact. But I live in in Windsor, Canada. So most of the engineers in my town, they work in US, live in Canada. So we make the best out of the both side of the border. So I have about 22 years of the industrial experience, as I just said, and then my education also I just briefly mentioned. So that's in a nutshell who I am. Now, I'd like to jump into the brief history of the automotive industry. So if you look back, it dates back to more than 200 years. So 1769, first military tractor was built and built out of the steam engine. And then after that, there was a first IC engine and another IC engine. And then in 1881, a formal three-wheel automobile was invented with the IC engine in it. But the modern day automobile as we know it today has been credited to Carl Benz, which is nothing but the Mercedes-Benz inventor or the owner or whatever you want to call it. The first time he introduced four-stroke engine into the vehicle. And from that point on, they actually led the industry for a few years, and then they switched to more of the pricey cars rather than the mass. In 1890, on the French side, the Peugeot, they used the Carl Benz invention and they started producing the Mercedes vehicle as a mass production. On the American side, 1877, the first American vehicle was designed, and then in 1893, the first vehicle rolled out. After that, in 1902, or at the turn of the 20th century, they started working towards the mass production of the automobile industry, which means that very quickly, those inventors realized that this industry is not a small industry. It is a large scale industry. So right from the beginning, they started thinking that if they don't produce efficiently and quickly, then it won't be a viable business. So this is what they did. And then in 1914, Henry Ford, their famous Model T rolled out of the assembly line. And the cars came off of the assembly line in 15 minutes and traveled much faster than the previous method, increasing productivity eightfold. And from 1920 onward, it has been produced in a mass numbers. And beyond 1920, the industry kind of, you can say that, okay, now it is well established, and the entire focus went into the achievement timeline of the component, subsystem, and the system. When I say component, subsystem, and the system, you start, let's say, from the wheels to the brake to the steering to the suspension and all of that. All of these components and subsystem and the system had evolution or evolved. For example, the cruise control, right? So the cruise control is not new. It dates back to 1950s, but it came into the production probably a couple of decades later, but it was invented a lot earlier. That's just a snapshot of the Carl Benz and the Ford Model T assembly line back then. On the EV side, to our surprise, or at least to my surprise, as I went through the history, that in 1898, a 22-year-old Ferdinand Porsche designed his first ever automobile, an electric powered car, officially known as Egger. And after that, in the 1900s, which is at the turn of the 20th century, the EV actually were outselling the gasoline cars, and people liked them because they didn't smell, vibrate, or make noise, and they were easy to drive. And that, I mean, we're talking like 120 years ago. Now, in the 1920s, so during the 20s, the EV ceases to be a viable commercial product because a number of the factors cause its downfall. For example, people wanted to drive longer distance, so the batteries did not hold charge long enough for them to drive, and the lack of the horsepower. Horsepower over here means that the power available to pull the vehicle, or let's say if you need more power, because every time, and this is the man's nature, that they they very quickly get into the mindset of the speed. And one of the evidence is that as soon as the automotive industry started to realize its potential, then they went into the racing part of it. And right there, they needed to see, okay, whether we have the enough power available to drive the vehicle fast enough and for a longer distance. So at that time, because no passion was there to develop the battery side, and at the same time, probably the oil companies, they lobbied with the legislator to make the availability of the oil much easier and cheaper. So the focus did not shift to the development of the battery side. And then every now and then there's a fuel shortage, which caused another wave of the thought process, okay, let's go away from the fossil fuel and start working on the EV. So another such push came in the 1970s when there was an oil embargo, and the automakers started thinking, okay, let's start working on the EV side. 1977, Volkswagen, they introduced their first electric taxi. And from that point on, the development of the battery side and then the distance and all of that, not full-fledged, but it's still they kept their work going in that direction, but not in a full-fledged as we see today. So 2011 was another turning point in the automotive industry where pretty much all the automakers they started to push and have a renewed push in the direction of the EV. And that's primarily, in my opinion, has to do more with the green environment initiative. So if you start from the Europe and then we come to North America, all we hear is that, okay, the emission levels are so high and we need to do something about the emissions coming out of the vehicle. But to me, this is still more of a political than anything else, because nobody touched the aerospace industry for that matter, or marine industry for that matter, or other large-scale industry, for example, the power plants and the steel industry for that matter. But they always pounded the automotive industry like anything, and they pushed them to the wall. Okay, do something about it. And it was until it was the 1970s when the automakers started putting the catalytic converter in their vehicles so that the emission that comes out of the tailpipe is cleaner, or at least it should meet the emission standards set by those Environment Protection Agency across the world. And some politics played by the oil companies to some degree, but the EV is not new. It has existed before, but now the push that we see in the industry is irreversible, in my opinion. So if we look at the current automotive industry, the EV side, from 1997 up until the real start of the big push towards the EV, it is remarkable and it is irreversible. Now, before we go into the EV side, we first need to see how big of an industry it is, because many of our engineers who are not working in the automotive industry, they probably do not have the idea of the size of the automotive industry, that how big that is. Size can be gauged by the volume they produce. Size can be gauged by the number of engineers that it has, or it involves, or it engages, and the other support and service industry that go with it. So if we look at the world automobile production data, like you see on the chart to the right, it does go very close to 100 million new vehicles made a year. 100 million. Now, if we look at the number of vehicles on the road, that's probably 10 times more than that. So we're talking about total number of vehicles on the road. It could be in the hundreds of millions. That's how big the industry is. If we look at the engineers' data, and the data you see on the screen is only from the United States, So in the manufacturing, whether it's a motor vehicle or the part manufacturing, we're talking again in the order of million engineers engaged in the industry. And if you go into the retail and trade and the mechanic and all the other side, then the number is twice as much. So from that, you can gauge that how many engineers they engage into this industry. Now, what are the potential for those? That's the next question that come in the mind. When people are not associated with the automotive industry, what they think is that it's only the automotive engineer or maybe the mechanical engineer has to do with the automotive industry. But that's not true, especially now when there's a big push towards the electrification of the vehicle, towards the autonomous driving, towards the new marketing model. There are a variety of other engineering and non-engineering discipline involved and are attracted into this industry. I'll show you in the next few slides. So from the size of the automotive industry, I've written a few names over here, but the names are a lot more than this. You don't see any Chinese name over here yet, but just for the sake of it, because we have the presence of these organizations in Canada. So what we have is the OEM. OEM stands for Original Equipment Manufacturer, which means all the nameplates that you see out there, for example, Chrysler, Ford, Toyota, Honda, GM, and so on. Those are OEM. Now, the most OEM design and produce are the propulsion system. And the propulsion system is nothing but the one that generates energy, whether it's an engine or the battery nowadays, or let's say the hydrogen fuel cell if we go more advanced side. And the other thing that they own and focus and manufacture or design is the external body shape and design. So these are the two primary items that every OEM in the entire world make. Everything else that go into in the automobile are made by what we call as the supplier. And within the supplier, there are tier one supplier who directly interacts with the OEM. And then they have tier two supplier that interacts with tier one and tier three supplier that interacts with tier two. The supplier industry is probably 5 times bigger than the OEM industry. Not just that, we also have the supplier of the software. This is just an example. For example, to operate a vehicle, you would think that you just start the vehicle and off you go. But while you're driving, you're not knowing that the software is involved. For example, if you have an automatic transmission vehicle, then you as a driver really don't care when the vehicle switches to the next gear, because it is hard coded with all the data in it that if a vehicle sees a ramp up the ramp or down the ramp, or if it has more load versus less load, then it switches the gear from one to the other. And all of that has to come from the coding that goes into it. So this is a very simple example of it. When we go from ICE to the EVs, the battery has a whole battery management system. And I think it requires a whole new lecture on it, that how they manage the battery and how they charge and discharge based on the battery, how the battery ages and so on. Anyway, so on the software side, we have the vehicle operation, CAD, CAE, diagnostic analysis, and the list goes on. And on top of that, we have the other service and specialized industry. For example, let's say battery. It is new to the industry, especially the lithium-ion battery. I'm not sure how many of you know that the lithium ion is combustible at room temperature if it meets certain conditions. So this safety is the biggest problem. And because it is new, pretty much all the OEM, they do not have the testing facility of that battery in-house. They started to build it, but they don't have it as we speak. So, but there are labs outside where they go, where the OEMs go and do their testing. Whether it's a Chinese automaker or Korean or Japanese or US, you name it. Very few of those, they have in-house battery testing facility. And that's just one example. There are, the testing happens for each and every component at the component level, at the subsystem level, and at the system level. So that industry also supports the OEM. All of this combined, you can see how big the industry is. Yes.
Sorry, Wes, interrupting you for a second. Just reminding all the participants, if they have any questions, they can definitely ask and try to make it interactive. Wes will answer your questions as well. And if you want, you can maybe type in your questions in the chat as well. So that.
Sure.
Okay.
And if you keep an eye on the chat, if there is any question, let me know, because I have my screen shared, so I don't see the participants on the other menu.
Okay.
Can we verbally ask the questions, or it's only in writing?
No, you can ask.
You can ask. You can ask, yeah.
In between or after the presentation?
So if it's a quick question, you can ask in between. If you think that it requires a discussion or debate, then we can take it to the end.
Okay, then just one question. You said lithium-ion batteries can explode at room temperature. Am I right in my understanding?
The lithium ion as an element is combustible at room temperature if it meets certain conditions.
Okay, then I'm really surprised then how it survived into an electric car, because you have in summertime it's very high temperature outside.
Exactly. That's a really good question, and I love it because I work on it. So what happens is that we have the cooling plate underneath. Whether you are charging the battery or you're discharging the battery, your cooling circuit is always on. So what we try to do is that we try to maintain a certain temperature of the lithium-ion battery. Lithium ion is just the ion, right, which flows from cathode to anode or anode to cathode, depending upon charging or discharging. But it has an electrolyte in between that helps ion flow. So this whole cell temperature has to be kept below certain temperature. For example, 80 degrees is, as a rule of thumb, we don't want it to exceed, but we try to keep it below 50. Once the temperature of the lithium-ion cell reaches 80 and beyond, the anode starts to disintegrate, and that disintegration is an exothermic reaction. And as you can imagine, when exothermic reaction take place, you expect the temperatures to go up. When the temperature go up, which means that now the electrolyte itself starts to break down. And that breakdown also is an exothermic reaction. And hence the temperature goes up even further until the other electrode starts to disintegrate, and then the vent gases come out. When those gases come out, they have combustible species like methane, ethane, and carbon monoxide. And they are at an elevated temperature because of the exothermic reaction. So all they need is an oxygen outside to go up in flames. So what we try to, in this whole thing, we call it thermal runaway. So if you remember a few years ago, the Samsung phone had many incidents of the battery going up in the flame, was primarily because of the thermal runaway phenomena happening, which means that their cooling mechanism or the heat sink was not working. So the whole idea behind having the battery at a controlled temperature is a big task for the automakers.
Thank you.
Sure. So on the CA side, for example, on the software, because I work on the CFD part, so I thought that I should put on various different software which are used in the automotive industry, or the areas in which we use the computational tool. So those are displayed in here. So if you are more interested on the structure side, then you have the possibility to go into let's say the FEA analysis, crash analysis, vibration analysis, and so on, or even dynamics. And if you are into, let's say, chemistry, on the IC engine side, you have the combustion analysis. And now with the battery side, you have the chemical reaction going on within the electrolyte, or what we call is the electrochemistry. So variety of different areas are there where we use the computational tool, which help us design or meet the targets set forth by from the safety concern or from the other perspective. The other thing I like to point out is that when we have the lithium-ion battery pack, when you're driving, and if anything happens to the battery from the structure point of view, for example, a stone hit or a nail penetration or an accident, so the lithium-ion cell is nothing but a galvanic cell. Yeah, where you have two electrodes and then you have a membrane that separates the two electrodes in between. If, as a result of an accident, that membrane gets ruptured, that again initiates an internal short circuit, which is again an exothermic reaction. Temperature goes up, then the battery goes into thermal runaway. So now, who is automotive industry is for?
Excuse me.
So what I've done over here is to create a baseline. A baseline is that, okay, if anyone is interested, especially our young engineers, first and foremost is the understanding what automotive industry is, how it carries its engineering forward, and how it strives to get in the talent and make effort to retain the talent. Baseline is expected to grow deeper with product evolution, tools development, and so on. All the automotive industry, not just the one that I'm working for, but all the automotive industry in US, Europe, China, Japan, Korea, you name it, they attract young minds. They attract young mind under the program, let's say the internship or co-op and so on. And you wouldn't believe that we've been asked to treat those students like prince or princess. And we even are asked to give them access to the higher management. And at the end of their co-op term or internship term, they also have an opportunity to present their work to the higher management. All of this is to attract them to the industry because they are young mind with the good ideas so that we could retain them and make the most out of them. So the first and foremost is the passion. If you have a passion, then I think the automotive industry is really dynamic where you can do a lot. Whether you are a mechanical engineer, electrical, automotive, industrial, controls, you name it, the list goes on. And if you are experienced like myself or many of you, whether you have the experience in the product development, program management, designing, data analysis, software, test engineer, all of those are needed in that industry and they are consumed. And as I mentioned earlier, that there are lots of specialized lab that provide the testing facility to the OEMs and also to the suppliers. And there are organizations and the schools who have specialized courses for the engineers who are working in the industry. Data analysis is another one that if you can go out to the company, they can analyze the data for you and of course, the consultation. R&D. So you'd be surprised that how many patents does the auto industry hold? I think it is number 3 after the software and the electronic chip related thing. But to give you the data, for the past 10 years, the number of patents filed were in excess of 100,000 from all the automakers combined in the world. And number of patents granted is probably 80–90% of the number that we file. So the patents coming out actually tells you that there's R&D going on. This is one thing. The other part of it is because automotive industry is also very protective of its invention because of the fierce competition out there. So they don't want anybody else to copy what they do. And if they want to copy, then they pay the copyright and so on. So, and the list goes on. This is just a sample for you to see from where you can bring in the engineers into the automotive industry and benefit from its dynamic, very dynamic nature. Now, we get into the EV side of it. So the automotive industry future, of course, it is an EV. And it's a bit of a political as well, but the push the automotive industry had over the past 14, 15 years is primarily driven from the emission perspective or the environment perspective. Before that, the push was driven by the fossil fuel reserve depletion and so on. And before that, we had a time when people started talking about the ozone layer depletion and whatnot. But right now, it is more to make the environment green. And unbelievably that those legislative body, they pound the automotive industry like anything, because the automotive industry across the globe does not have a strong voice in the legislative body of each country. If I take an example of United States or Canada, the oil and gas companies, they have more influence over the legislation body than the automotive industry. So they get what they want, but the automotive industry has to struggle a whole lot before they get anything out of it. For example, people are struggling to buy or they're not able to make their mind to buy the EV or totally switch towards the EV because of the variety of different reasons. I have a slide for that too, but they say that the range is one thing, price is another thing. So when we talk about the range, it has to partially do with the support from the government. For example, if you were to drive from, let's say, Windsor to Niagara, whether I have the Tesla Model S or Model 3 doesn't matter, I cannot go in one charge. Because the way the battery pack is designed, that it is only usable between 20 to 80% of its charge. Beyond that, it's advisable, recommended, and hard-coded not to use it, and so on. Anyway, so
can I
yes,
give you an input over here? I'm
yes.
driving a Tesla Model 3. I don't know what's the distance between the place you were mentioning, but I go all the time to Niagara Falls and come back without any problems. It's more than 100 kilometers, and the maximum, if it's 100% charged, it gives me 537 kilometers. So if it's 90% charge, you can imagine it's about 400 kilometers, and it's quite comfortable for me.
I see. So I think it's a very positive feedback. I like that. I live in Windsor, so the Niagara is about 350, 370 kilometers away. And we have a couple of friends over here who own Tesla. And oftentimes, and it really depends on how you drive, because the drive cycle matters a lot. What they write in the book is based on the drive cycle that is published as a standard, right? So if you follow that drive cycle, then you're good. But if your drive cycle includes more of the ramp up, or let's say the speed up where you need more torque and whatnot, oftentimes the car will say, okay, I cannot go beyond this point until you find me a charging station and charge me for 10 minutes, and then you go on. So
can I ask one question?
Everybody has to mute, please.
Excuse me, Asma, can you mute yourself?
I'm mute.
OWAIS, can you
I'm
elaborate
mute.
what,
It's someone else, actually.
yes, go ahead.
can you elaborate what the P and M in the abbreviations that you are using? PHEV?
Yes.
H is for hybrid, but what are P and M for?
Okay. So we have the internal combustion engine, which is ICE. M is still a hybrid, but it's a mild hybrid. And then the HEV is a
Can you repeat mild? What do you mean? Mild?
Mild,
M-I-L-D.
M-I-L-D, mild.
Okay.
Mild hybrid. Mild hybrid includes, for example, you have a stop-start feature in your vehicle. And if you have, let's say, the e-torque available as a feature in your vehicle, so what the e-torque does is a small electric motor which gets charged as you drive, and then it helps provide extra power to the transmission to multiply the torque. So you save energy from the ICE. So we call it mild hybrid. And then the PHEV is the plug-in hybrid. So the Japanese automakers, I think they try to make their point with the US automakers that don't go full-fledged BEV, which is the battery electric vehicle, which means all electric vehicle, which means no ICE. But they didn't listen. So now they're paying the price of it, because until or unless we have the infrastructure in place, then the PHEV has a better future for the next 5 to 7 to 10 years. And then once the infrastructure is there, then of course you can go ahead with the BEV full-fledged.
Thank you.
So if you look at the Europe was leading in the electrification of the vehicle. Don't be deceived by the percentage, because percentage, is relative to the volume you have, right? The most volume is still in China, and then comes the Europe, and now the US has started to pick up. So that's the distribution of the ICE versus the hybrid versus the others. So automotive industry future. So if we look at the propulsion system, we have the electrification, which is aimed at zero emissions. A lot of work required in there. And you wouldn't believe that the automotive industry hires left and right if they find anybody who's good in chemistry that can do the electrochemical reaction analysis, or can do the electrical part of it, and so on. And of course, the innovative propulsion system, which includes the hydrogen fuel cell, if anybody is expert in it. But that development is in parallel to the lithium-ion batteries that we have at the moment. The next big thing in the automotive industry is the process automation, which means that there's smart use of the existing database to help produce better product. The automotive industry has a wealth of data. For example, if I take the example of the internal combustion engine, they've been producing it for 120 years, right? They have the data. Ideally, using that data and do the modeling, let's say what we call is the meta modeling, and then interpolate or extrapolate so you can save your development cost and time. And of course, the use of the virtual simulation like the CFD or the FEA, where you can have more in-depth analysis of the data, and then you save the cost on the hardware and so on. And then comes the autonomous driving that has to do with the coding, with the communication, with the controls, and so on. Innovative marketing, you'll see in the next few slides that how China is marching forward in bringing in new concept in the marketing part of it. Industry consolidation, we had a CEO who died a few years ago. He said that in the next couple of decades, the entire world will only have 10 to 15 automotive industry, which means that the scale of the work is so big that it is only viable if you have very few but large operations with a larger profit margin. So the automotive industry future, as you can see, that the Tesla Model Y versus 3 versus the Chinese market, and then so on. So if you look at the data in the United States, the Europe, and the China, you can see the numbers, how good or bad they are. So the US is catching up with Europe, Europe catching up with China. That's the equation. And the China is now bringing in a new safety regulation for anyone who wants to sell the EV vehicle in China, non-Chinese. They have to meet a very strict safety requirement because of the combustible nature of the lithium-ion battery pack. This is just the volume data, how it grows. But what I want to show you is this one. The non-automotive players are also competing to launch BEV, battery electric vehicle. When we say BEV, BEV means no engine in it. So after a first step in automotive world through collaboration with Chinese OEM, ID smartphone players are now working on future BEV. And one such example is the Google. Google has a company called Waymo. What Waymo does is that they're working on the robo taxis. So a few years ago, my company where I work, they gave Waymo about 900 vehicles for them to instrument it with the sensors and receptors and controls. And then they've been trying to work on the autonomous driving. We have a town in Michigan called Ann Arbor. In Ann Arbor, there is a
Excuse me,
small.
Munir,
Yes.
can you please, you are host, so can you please mute the ones who are unmuted? Because I can see that there are so many participants who haven't muted their mic.
Where's mine? Mommy and
So the
Mama
autonomous testing has been going on all across the globe, and one such testing is done very close to Detroit. There's a town called Ann Arbor. So if you had an opportunity, you can go and check it out to see the unmanned vehicle driving around on their test tracks and so on. What's next is that the marketing strategy. So there's a company, BAAS, which is the purchase of vehicle without the battery. Because people are complaining that they cannot get the range and the charging stations will take more time for the battery to be charged and so on. So they can purchase the vehicle without the battery. And BAS proposed by NIO, which is another Chinese company, that they can swap the battery. Like you go to the gas station, you take your electric vehicle to the battery swap station. So it will take 3 to 5 minutes to swap the battery and off you go. So this is how you can save time on the charging part of it. And that's been going on for a couple of years already, especially in the Scandinavian countries, because Chinese have captured pretty much entire Scandinavian market already. So this new way of selling convinced 92% of the neo-Norwegian customers in the year 2021. The other part is the phygital relationship, which means that online sales, and then what you do is there will be a whole host of maintenance and repair services, and where you only lease the vehicle, you don't worry about its maintenance, and then they will take care of it. And the cost is not high. For example, over here, 1 to 11 month lease in Europe is about 500 euros a month. That gives you about 1250 kilometers a month, and everything included: insurance, maintenance, roadside assistance, and so on. 95% of customers in Netherlands, Sweden, and Italy who are hooked up with this, they are pretty happy with it. Now, European Commission enacts a law that protects to stop the sale of new cars with thermal engines by 2035. This is very aggressive in my opinion. In the Europe might be okay because the volume is low, but in the US and Canada, because the volumes are high, they might not be practical. And I believe that the automakers are doing their best to work with the legislative bodies to just relax this rule and not push on it too much. So the timeline based on that is such that on the Europe side, The 2024, if you look at it, Alpine is a company that have all electric, Jaguar. Then in 2027, the Alfa Romeo, which is one of our brand, 2030, they put the Stellantis logo up there, but not all the name tags would be out there, but a few of those, and so on. The automotive industry, the main reason for the rejection of the EV side, for example, many of the folks who are more into the ICE or they just don't want to move to the new technology so quick, and for the valid reasons. So based on a survey, what they think is that the price is the main factor for them not to go in the direction of the EV. And then comes the range, and then comes the charging equipment. In my opinion, if you ask me as an automotive engineer or the engineer working in the automotive industry, I would go in the reverse order. The charging equipment, which is the speed in the network, to me is the primary reason not to go all EV at this point in time. And then I would go and look into the range, and then I would go into the pricing side of it. So, but the survey results came out like this, that the price is the main factor, followed by the range, and then the charging equipment. So as a wrap up, what I can say is that the size of the automotive
Just one
industry.
question. The survey
Yes.
you quoted, how old is the survey?
This is probably 2021 or 2022.
Okay, thanks.
Sure. So as a wrap up, like I mentioned early on, that the size of the automotive industry is huge. It produces vehicles in excess of 90 million worldwide, and it employs millions of engineers worldwide. And the list goes on when we talk about the size of it. Evolution and innovation. So 100+ years evolution history it has. Whether you talk about small components such as the shock absorber, which is the same for the electric vehicle versus the ICE, then it has its own evolution history. And innovation aimed at becoming tech company. Like you saw a couple of slides earlier, that the non-automotive companies are also interested in producing the autonomous cars. So that potential is also there. The growth in potential, for example, the growth in the product volume is always there. People talk about India as the growing market. The next big market is the Brazil, though the population of the Brazil is probably the same size as Pakistan, about 220 or so million. But it is the fastest growing in terms of the volumes of the vehicle sold in Brazil. So the product volume will grow. And this is just one example. India is another example. But if we go the other countries where the population is big, for example, Indonesia and whatnot, as they prosper, the next step people do is buy the vehicle. So the growth in the volume is there. And then comes the technical growth. Because the automotive industry keep on adding new features and technologies into their vehicle, then practically there is no limit to it. For example, automotive industry, it takes the inspiration on the technology side from the aerospace industry. For example, cruise control to the airbags and to, the other thing, for example, the autopilot kind of thing. Many of the inspirations come from the aerospace industry. And now the inspiration is coming from the other areas, from the communication side and control side and so on. If the industry is big, volume is big, then of course your technical network is also big. So you grow on your technical network. For example, one of the biggest conferences that happen in the Metro Detroit area is the SAE World Congress. And you wouldn't believe the amount of research articles are presented in that conference. Though you may call it not a very quality product, not a very quality research article, but primarily because the automotive industry does not want to disclose everything out to the public. But the amount of research articles or the presentations made in that conferences is huge. And that's just related to the automotive industry. Global or regional. This is a very attractive thing to know, that whether you have experience working with the auto industry in a third world country or a first world country, your experience counts. I have seen many engineers with the automotive experience in Pakistan. They come to the North America, they get absorbed in the automotive industry right away without having to go through additional education or certification and you name it. So a lot of growth. Feel good factor. How many of us who, as an engineer, work on a product and then use that product, right? So automotive industry is one such industry which, at least myself, I can gladly and proudly say that the car I'm driving has a battery or the engine that I worked on. So in this way, I have a unique level of ownership associated with this industry, that, okay, for example, for the past 5 years, the car that I'm driving, it has an engine which goes across the board in many of the vehicles that Stellantis make. And people like it and I like it. So I can tell. And now we're working on the battery side. So once I hop onto the EV, then of course I will have the same feeling that, hey, I worked on it and I'm driving it. So that's a feel good factor always there. So with this, I conclude my presentation and open the floor for questions if there are any.
Wes,
Yes.
can you hear me now? Hello.
Yes,
Well,
I
Yeah,
can
we
hear
can
you.
hear you.
It's an excellent presentation. Thank you very much for putting it. One question I have, that in between these convention engines, there was a time when rotary engine came in and
Yeah.
it died off very fast.
Mhm.
Do you have any inputs for that?
I don't, but I believe that it has to do with the efficiency, whether it's the thermal or the mechanical. In both cases, I believe the rotary engine probably lacked the mechanical and the thermal efficiency.
Okay, thank you.
OS, this is Javed, and I'm here.
Mhm.
Very informative session, I would say. Just
Mhm.
a quick question.
Mhm.
We were given to understand that EV manufacturers will probably replace the gas cars on a short time, on a
Yeah.
very short time.
Mhm.
You mentioned some reasons during your presentation.
Mhm.
What do you expect? How long it may take, and how those obstructions could be eliminated? And the second question is, what do you see? Every discovery, every invention, every change has an impact on the social and educational domains. Do you
Mhm.
foresee some changes after EVs are kind of got popular or get popular?
Yes. So let me answer your first question first, which is the reason behind quick or not so quick transition from the ICE to the EV, right? The push this time around towards EV was primarily driven by the green environment or the regulation made by the EPA, the Environmental Protection Agencies across the globe. So every automaker has started working towards that. Now, at the same time, what should have happened is from each of the government across the globe should have worked to upgrade their grid system. Imagine if you live in a housing where you have 200 homes, but right now only 10 homes have EV. Imagine if 50 homes have EVs, then we might face the load shedding like we see in Pakistan or Karachi, right? So that part, the government has not taken into account or not working on it as we know. Very little. One other example, for example, the LG and Stellantis, the company that I work for, they combined are building a battery plant in Windsor. That battery plant was delayed by about 6 months only because city of Windsor needed to upgrade their electrical supply system, whatever you want to call it. So that part where the government needed to play a role, is still non-existent. And that's one of the reasons why that it may not happen so quick as they thought it would. The hope was that by 2035, the ICE will be out of the picture, but I don't see them going out. But at least the immediate future is the plug-in hybrid, where you have a small engine hooked up to to charge the battery, which the battery can also be charged while it's not running by hooking it up on your grid system at the home or in the parking lot or whatever. That's one thing.
OWAIS, I have a question.
No, next question, OS, if you
Yeah.
could answer about
Yeah.
the impact on social and educational domains. You
Yeah.
know, every discovery, every invention, every change has an impact. So can you highlight, or can you tell us what could be the expectations?
Yeah, this social impact, probably I'm not qualified to talk about it, but from the educational perspective, for example, couple of decades ago, we heard there is a new engineering discipline called mechatronics, but that didn't fly. So which means that the time has come where the jack of all trades will now work. So you have to be specialized in one area versus the other so that you can make most out of it and you can contribute a lot. The EVs have opened up a lot more venues for the people to get engaged in. One such thing is the software. The other is the control side. And the third is the communication side. Out of these three, for example, controls is one of those areas where a mechanical engineer can easily adjust himself or herself into that area, because the controls has to control the mechanical devices, component system, subsystem. So I believe that going forward, the schools have to adjust it in a way that they introduce more specialized area, maybe postgraduate studies. The social impact, I'm not sure if I can comment on it.
Yeah. OWAIS,
Thank you.
Yes,
Thank you,
one
OS. Thank
I have
you.
the next
Thank you.
question here. I'm Sharif. Can you hear me?
Yes, I
Yeah.
can hear you.
Yeah, OS, it's a very nice presentation. I would like to know, there's a lot of investment coming in Canada for making the battery manufacturing plants here. And I know because I'm involved in many of the projects here, and most of the projects are now getting delayed. The fear is that this lithium-ion battery may be out of the scene in next few years, because there are some new type of batteries coming in. That people are talking about solid-state batteries. So do you know anything happening in this? Because the sales of Tesla has come down 20% in this year, in 2024. So what would you say on that?
Yeah, the automotive industry is so big. Whenever they plan it for at least 2-3 generation of the vehicle. For example, like I said, that the OEM makes the contract with the part supplier, and battery pack is also a part supplier at the moment. So for example, if a Stellantis needs the battery pack for its range of vehicle for another 8-10 years, then those 8-10 years are fixed. Those are not going anywhere. So the lithium ion will still stay until the solid state batteries are out in the market and tested and all of that. And of course, I do hear good things about those, especially from the safety perspective, because they don't catch fire as such, and the thermal management is a lot more easier. But I believe that the lithium ion battery is a good transition in between, with the exception of the safety concern of it blowing up in certain conditions.
Yeah, and because I heard that they're coming up with a battery, they're doing research on that, and maybe in next 8 to 10 years, the batteries, the weight of the battery is very low, and it can be charged in 10 minutes and good for 1,000 kilometers.
Yeah, that is a very good dream, but I think it needs
It's
to be
not a dream.
realized.
I read it because I do a lot of research on it.
Correct. I mean, I'm not ridiculing it, but what I mean is that it has a potential, but then it has to be materialized. For example, I mean, I give you one example. I'm not sure if you've ever been to the auto show yet or not. In the auto shows, we see a lot of concept vehicles. So if let's say 20 automakers, they bring their concept vehicles out there, a part of the feature makes its way into the production side, not all of it. So the solid state batteries, because it is in the development stage, it has to come out, tested, and then the automakers has to buy it, buy the technology in a way that yet it is a good option. So I think it is a good option, but it will take a while.
Yeah, but my vision, or you can say the wishful thinking, is that it may come true in
Absolutely, yeah.
next couple of decades. Is that
Yeah, 10
that
years is a good
there'll be-
time. Yeah,
Yeah, there'll be an electric car
yeah,
where you have solar cells all around the body, and you never have to charge
yeah,
it because it's charging
yeah,
with the light available, and it's not really the sun; it's the light available in the
yeah.
atmosphere.
I'm not sure if you had a chance to see the autonomous testing vehicle or not. When you see it, you see a lot of sensors attached to the vehicle. When you attach the sensor to the vehicle, it loses its identity in terms of the design, you know.
Okay.
So this is another fight that we go through between the artist and the engineers, right? The artist will come up with a very nice design of the car, the exterior of it, but then the engineers would come in and say, hey, it will not work because it will add more drag to it, and so on and so forth. So that fight is still needs to be won for the autonomous vehicle to be practical, and of course the battery side, the same thing.
Well, say in your
Yeah.
opinion, which hybrid is better, a plug-in or HEV, which uses the braking system?
Everyone uses a braking system that regenerates the power, but the plug-in hybrid is the way to go, in my opinion, because you bring the car home, you hook it up in the morning, off you go on the battery 100%. But if you have hybrid vehicle, then it starts out, I mean, if the battery is not charged, then you start out ICE, and then it will charge the battery, and then it will switch back and forth. So PHEV has a good immediate future.
Because in my as per my experience, if I'm running the HEV inside in the city, it's working okay. But once on the highway, then ICE engine takes over most of the time.
Because those batteries are not as big as the batteries in a battery electric vehicle, which has no internal
Right.
combustion engine. City driving requires less power, lower
Yeah.
speed. That's why.
Low speed. Yeah. On highway, it is above 90 or 100 kilometers, then ICE take over here.
Yes. Asad bhai has a question.
I have one question, please.
Yeah.
Yeah, this is OWAIS. The electrical vehicle normally are promoted on the basis of the environmental positive impact.
Mm-hmm.
But is it not negated by the power source that is being used to generate the power for the vehicle? So actually, it negates that impact. So what do you say on that?
It's a very good question. And the answer is also very simple, that if the power generation is off of a thermal power plant, then well to wheel, you're not saving anything, like in terms of the environment. The environmental impact will be there if the energy comes from the thermal power plant. However, if the energy comes from the solar or hydel or nuclear or geothermal, then of course the impact is very positive.
Okay, thank you.
We are going over time, but I'm okay if everyone is okay, because the discussion is going really interesting.
Asma?
So we
yes.
can leave for another 10-15 minutes. That's okay with us.
Yeah,
Cool.
I'm fine
excuse-
with it. I have a couple of hands up over here. Asad
Exactly.
bhai and
Yeah. So we will
Rafi.
take these questions. So thank
Okay.
you.
Sure.
Mm-hmm.
Yes, Asad bhai?
If nobody is there, Wes, can I
Hello?
add something here?
Yes, Asad bhai, go ahead.
Hello, Wes. Thank you for very
Sure.
nice presentation and slides. I like the slides very much.
Thank you.
And also thank you for appreciation and public acknowledgement. I will change the topic slightly.
Uh-huh.
When I look at new cars and look at Honda, Toyota, all of them, they look
Mhm.
alike. So
Yeah.
I have a question about aerodynamics. Like, is
what
there
do you
only
do?
one company who does aerodynamics for
No.
all the companies?
Yeah, it is
All-
the same
Each and every OEM, they do their aerodynamic design themselves. Like I mentioned a few moments earlier, that the overall design of the vehicle, it starts from an artist. The artist will make the clay model out of it. And then that clay model will be digitized and will go to the aerodynamics engineer to begin with. So what he will do then, he will do the simulation on the aerodynamics part of it to see if it meets, let's say, the drag targets or not. If not, then he would suggest the design changes. And this is where the fight begins between the artist and the engineer. Hey, you're destroying my design. So
Yes.
every automakers have their own team to work on the aerodynamic design.
But why they look same, all of them?
There's a limit to the shape of it, right? And also the
Yes.
competition too, right? I mean, oftentimes the competition drives the overall shape of it.
Yes.
Yeah.
And also on your
OS
slide 11,
Uh-huh.
you know, we share our aerodynamics passion.
Uh-huh.
So on your slide 11, you have no software for, I think it is the list of software for aerodynamics.
Yeah. So I mean, if you want to know which aerodynamic software is used in the industry, so there are many. So it start from, let's say, the Star CCM Plus owned by Siemens at the moment. Before it was CD Adapco. And then we have the ANSYS Fluent, and then we have the OpenFOAM, and then we have the PowerFlow, and we have a couple of others which are out there in the market. But most OEM, they use the Star CCM Plus, Fluent, and the PowerFlow.
Okay. Okay, good.
Yeah.
I have one comment
Thank
about.
you. Thank you, Wes.
Sure.
Sorry to. I have one question and one comment. The question, rather request. Can we have your email address if we want to contact you?
Absolutely.
Or,
Yes.
So I don't know, like, was it in the? Can you put it in the chat box or somewhere?
Yeah, I can write in the chat box, no problem.
Yeah, and the second one is a comment about your comment regarding mechatronic program. It has not disappeared. In fact, I teach in a university, and mechatronics is one of the most popular program right now. So it is going strong in many universities, and so I think that it's because it encompasses most of the technology that you've discussed. So it is going strong, and one of the most popular ones. Yeah.
It at least opens up the areas where the student can go and find their passion, you know. So, but I think if you have the mechatronics, for example, I've been working in the industry for 17 or so years. I haven't seen a single resume that says that he has done in mechatronics. So my basis of making that comment is probably that, but I could be wrong.
Yeah, it's a growing program, so it's basically probably you will start seeing those
probably
resumes.
Sure.
Okay. OWAIS?
Yes.
OWAIS, I have another question, Sharif here. Because I'm studying this thing because of the atmosphere change or climate change. I've written a few papers, and I'm presenting another paper which will be done in October. Is it right that China is coming up with the cheapest electric car in the world? What I read is that about 15,000 American dollars is the price of the car. Is that right?
That is very right. And they are struggling. For example, the American administration, they say that you can sell for 15,000 if you make it in United States. If you make it outside United States, for example, Mexico or even China or somewhere, then you have to pay 200% duty. So the battle is at that point. If they make it in the United States, then of course, you know, the labor cost would be higher. So it won't be that cheap. So I don't think that it will materialize at 15,000 because with that price, no automakers who make their vehicles in North America, whether US or Canada, they cannot compete, right?
Tesla will close down.
Excuse me, Sharif, give other chance. This is Ghulam Malik,
Yes.
I'm a NEDAC president, so my main role is to help our members. So always you have done a wonderful job, and it was very nice presentation. But what I need a real help from you and your colleagues. Our mechanical engineers are getting really, really hard in getting the jobs. So you guys can, I think so. If I'm not wrong, you guys can help us in this area because I have seen many, mechanical engineer living in GTA. I think they need some kind of direction that where they can get a job. First of all, they need, where to locate and relocate and get the job. Because in GTA, there's no job for mechanical engineers.
Yeah.
So we have a, a NEDAC group, and I would invite you to join that group, or if you have not already joined. And I would request you to please, take a lead and add your other good friends in that group, and guide our mechanical engineers how to get a job in this competitive world. So that's my real request to you.
Absolutely.
And I hope you guys can help us in this area, and I will be grateful. And again, very nice presentation. Thank you.
Sure, absolutely. Yeah, I'll be there.
Okay, thank you.
Sure.
OWAIS?
Yes. Any other question?
Just a comment here, OWAIS. Sorry, I'm asking you too many questions. I'm just
no problem.
With this Tesla Model 3, I never dared to drive into USA. But one of my colleagues, he has exactly the same car. He said he has driven up to Florida with his family and came back. And then I said, how did you do the charging? So he said that the Tesla always displays where are the chargers and available. But the problem is that when you go to a charging station, you see 10 vehicles staying in a line, or out of 8 chargers, 4 are working and 4 are not working. So I think there is a big problem with the infrastructure. When the infrastructure is completely developed, then people will be more confident in driving long distances.
Exactly. I totally agree with you.
Yeah.
Do we have room for one question?
Yeah, Rafi Majid has a hand raised. Yeah.
Yeah, loved your presentation. OWAIS, that was
Thank
really
you.
cool. You being a bona fide a subject matter expert, both academically and in the professional area.
Number one is
one thing that you have busted a couple of myths, at least for me. For example, that contrary to the popular belief that EV is a fairly new phenomena, I now know that it dates back many, many years ago. But Tesla coming into the picture, and we may or may not agree that it disrupted the model.
Exactly.
So for the benefit of this audience, engineering audience, based on your personal opinion, OWAIS, is it the product engineering, or is it like a genius business model from Elon? What made it disrupt the industry?
Very good question, Rafi Bhai. First and foremost, we have to give credit to Elon Musk, because he was bold enough to jump into this boat, right? This is first and foremost. Number two, he started out from the geographical region which supported him big time, for example, California. So the California, it is so hard to sell the ICE vehicle in California because of the emission standards to meet the emission requirement of the California. In fact, they have a whole different laws than the rest of the United States, or even the entire North America, very close to Europe. So with that, he got the funding from the government, the state of California, as well as the federal government. The rest is the automotive industry itself, because he pulled people out from the existing industry, the best people. He paid them well. He worked for them, because battery and motor are the two new things that go into the EV. The rest of it is the same, right? You have the wheels, you got the suspension, you got the brakes, you got the AC system, you got infotainment, you name it. Propulsion system is new. And this is where I think he put more of his focus in, and he's probably the only automakers who manufactures the cells itself, lithium ion. Everybody else, for example, Stellantis, Ford, GM, Toyota, Honda, they buy their lithium ion cells or the battery packs from LG, CATL, and there are other Samsung and so on.
And I think
So,
that's the genius
yeah.
of Elon, that he
Yeah.
owns that factory.
Yeah.
And,
Yeah.
you know, you can actually see that.
Yeah.
If you can look at it from a business model standpoint, you may actually say that, you know what, Tesla is not an auto manufacturer, it's a battery manufacturer, because that's what their biggest revenue stream is.
Exactly. And let me tell you one more thing, that up until a few years ago, that Tesla was struggling to make money, right? So what they planned at that time is that let's not make it ourselves. Let's ask the existing auto manufacturers assembly line to make the vehicles for them. Because the vehicle manufacturing is a large scale operation, from labor to parts to space, and you name it, right? So they were at that point, why bother having our own assembly line? Get it assembled. So I think he's a
Anyway, thank
smart
you.
fool, yeah.
Yeah, that was genius. Thanks, OWAIS.
Sure.
Thanks to the NEDAC
Sure.
board, Asma, and everyone else. Such a cool presentation. Thanks.
Thank you. Thank you.
I have
Appreciate it.
one more question, OS.
Do we,
Yes.
can we take more questions, OS? I think we are 18 minutes over time.
Yeah, I cannot say no to Asad Bhai.
Okay.
It's just
then we
about
should,
the charging time. You know,
Yes.
like if I live in Kingston, I come to airport to pick somebody up and then go back to Kingston. I have to definitely charge my car, which takes like 45 minutes for Tesla Model S. It takes about 45 minutes from 150 to 100%. So is there any like work going on in fast charging, like in terms of like research on thermal cooling and all those
Yes.
things?
Yeah.
How big is
There's a
that?
lot of work going on, Asad Bhai. They call it DCFC, the DC fast charge. Not all the stations have the DCFC. And also not all the vehicle or the battery pack are associated with the capability of the DCFC, which means that you supply more current to the battery pack so that it gets charged faster. But the more current, as you can imagine, and more ohmic heat generation. And more ohmic heat generation meaning a better thermal management. So if the battery pack is designed for that, then of course, yes. If not, then you're stuck with the long charging time.
Yes. Yes, charging time, I think, is the, as you said, is the main issue. Like if I can fill gas in 5 minutes, then if I can charge in 5 minutes, it's fine.
Then it should be good, yeah.
Yes.
Yeah. Okay.
Thank you, Wes. I
Sure.
have to go, and
Sure.
thank you very much, and good to see you.
All right. Same here.
Thank you very much, everyone, for your participation, and make it an interactive and very good seminar. Thank you, Wes, especially for you.
Asman, can we have this? Is it possible that we can get this presentation and put on our website?
Yeah, I'm sure we are recording it.
If the doctor's job is okay, then we can use it, right?
Wes, can I ask you one last question? Just one last question. You are the best person to answer it. I heard that there's a Pakistani engineer in the United States who has come up with a battery which will be good for 1,000 kilometers. And Musk is closely working with it so that they can use it in Tesla. The new Tesla cars will be coming, where you charge the car and it's good for 1,000 kilometers. Is that right?
That is right. I've also heard about it, but I still need to look into this to see what technology is he talking about. Is he talking about solid state or something else?
Okay.
Yeah.
OS, one dream question. This is Javed here. Can we think of charging these EV cars through satellite with certain pin codes, a certain arrangement? Is it possible?
The remote charging also comes with the proximity, right? So if the proximity is not there, then I mean, with the current technology that we know of, it's probably not possible. But the proximity has to be there. For example, you can have the tracks where they have the remote charging facility where you drive over and you get charged.
That's
That's
what I
possible.
heard. Some part of the
Yeah.
world they're using
Yeah.
tracks to charge.
Tracks to
But
charge. Yeah.
satellite or anything else like
Yeah.
could be
You need a
used for
proximity.
charging.
Yeah. Otherwise, it would be everywhere. You know, I mean, it would be a health hazard, in my opinion.
Are you aware of the transmission and distribution of power, electrical power, without the conductors?
No, I'm not.
It's going on. It's still
working.
the research is going on.
It's working. No, it started in Denmark, and probably they are developing further. But I was just thinking that any charging could be done through certain distance, but maybe a satellite, maybe some other device, to like keep running the car on the road and keep charging. So one way you said is track, which I heard. Well, can it be done through like something in the air?
Yeah, I think we need to see what that is. Maybe Asma can look into it. She's from electrical side.
Asma and OWAIS, both of you.
Yeah, but I haven't like pursued electrical engineering per se, but definitely it's a very good, interesting topic, and we can definitely find out.
Thank you, Asma.
And
thank
everyone,
you, OWAIS.
whoever needs to directly contact OWAIS or myself, you guys have OWAIS's address in the chat. And my address, obviously, you have all received an email from me for this webinar. So thank you so much. And we look forward to see you all next week in the NEDAC picnic. If you haven't yet bought your tickets, please do so. It's going to be a very lively and very good, because it's summer, and the cruise there is nothing like having or going on a cruise and see our city from there.
Yeah.
So, OWAIS, can I ask you a question? Taking this opportunity,
can we take it offline, please, with OWAIS directly, or okay? If this is the last question, that's fine.
No,
Go ahead.
it was a personal request. I don't know. Like, I teach a course in a graduate course on automotive materials. I was wondering if you would be available to deliver a guest lecture sometime during the fall semester.
Yeah.
I would like to invite you to do that.
Yeah, that'd be okay, because I do teach at the University of Windsor the fundamental of automotive, which is also a graduate course, so I can do that.
My location is in East GTA in Oshawa. So I will send you the details. If you can make it, that will be wonderful.
Okay, no problem.
Okay, so I'm going to send you an email of the.
Sure.
Thank you very much.
Great.
All right, thank you very much. I appreciate it.
Thank you.
Asma.